Yo guys, so Solana tokens are becoming a real thing, or the meme tokens, they are really popular these days. I thought it was a good idea to create a video on how I created a simple token sniper. I will show you how I created one, all the building blocks that are involved, and then you can take away what you want and you can build your own sniper afterwards. So the sniper that we're building today is a liquidity pool hunter, so it actually checks when a new token is created on the Solana blockchain. It will do some checks like rug checks. It will see if it's a Pump.fun token, because the Pump.fun tokens these days, they are quite volatile. And if everything is good, then we will create a swap transaction and actually swap our SOL tokens for the new token. We will try to do this as fast as possible, of course, because we want to buy the token as soon as the liquidity pool is created. We will only look for liquidity pools from the Raydium liquidity pool market maker. But once the token is there, we want to buy it as soon as possible, and then we want to sell it whenever we have some decent profit. So that's the whole point of what we want to do today. I will show you a quick overview on how I built it. After that, we will jump into the code, and yeah, if you have any questions, feel free to put them in the comments and I will come back to you as soon as possible. Alright, so before we jump into the code, I want to show you a high bird's overview of how our sniper will work. And let's say that on the bottom we have the Solana blockchain here. The first thing we want to know for sure is when a token is created. So that's really important. Once a liquidity pool is created, we want to know this as soon as possible. For that, we will use a Websocket RPC. There is a lot of RPC providers out there, but for this video, we will use Helius. I will come back to what that is and how we can work with it later when we have a look at the code. But the thing is, this RPC will be able to talk to the Solana blockchain and provide us the logs with liquidity pool creations as soon as possible, almost real time. So once we filter these logs, because we will receive a lot of logs, once we filter out the ones that we need, the ones that are related to the liquidity pool creation, we will take that transaction or the signature from the transaction actually, and based on that signature we can use another API also from Helius and get the transaction details. So once we have the transaction details, we can export some pool keys, and pool keys are, for example, the Solana token mint, but we also have the new token mint that we can use then. Next, we can use this token mint to do some kind of rug check. Also for this, we have a third-party service that we can use. There is a really good API where we can send the token mint to, and we get some kind of report back with how the token looks like. Is it a dangerous token? Is it a okay token? Is it a medium token? So the report we will get back, and based on that we can make a decision if we want to buy the token or not. Once we have all this information, we can create some kind of document and send it to a swap API. Also for that we have a third-party service. Once the swap API receives our instructions, it will return some kind of quote, which in turn we can sign the quote with our own wallet, and that transaction, this swap API can then put on the blockchain and actually swap the SOL tokens for the new token. So that's a bit of an overview how the token sniper will look like. Once we look at the code, we can come back to this overview and exactly see at what step in the process we are. But for now, I think we have a decent idea of how the token works, so let's jump into the code. Alright, so here we have our code base. The token sniper is created in TypeScript, so if you're familiar with JavaScript or TypeScript, you will probably be able to follow really easy. If not, there is a lot of good JavaScript and TypeScript tutorials out there. So if you think it's hard to follow, take one of these really quick, like Introduction into TypeScript or JavaScript, and after that it will make more sense for you. So the token sniper actually starts from the index file where we have a function called Websocket handler. And this function is just a Node.js WebSocket library that we use here called WebSocket. And it will create a WebSocket listener for us. So the WebSocket you can import with WebSocket from WS. You can just Google WebSocket for Node.js and you will find more information. But we can create a new instance from that by providing the WebSocket URL. All my URLs are stored in my environment file here. I created an environment backup file because I don't want to expose the actual environment file because it holds my private key as well. But in here you can find all the URLs for the RPC, for the other API requests that I do. And these RPC URLs you can find in the actual documentation, because we are using Helius. I think if you go to Helius RPC overview, you will have a good understanding on where to find these endpoints. I think you just have to create an account, go to endpoints, and you can copy these links here. So as I said, for this video, I will use the Helius RPC nodes because I think they're quite reliable, but there is a lot different ones out there. In order to get these parameters into my code, I use a package called .env, and it's a zero dependency module that actually loads the variables into the script here. So once we created a new instance of WebSocket, we can move on and we can say that there is no transaction ongoing at the moment because we are not handling anything. And it's always good to know in what state we are into the program. So we have the diagram here. So the first thing that we are doing here is actually creating this WebSocket here. As you can see, the WebSocket that will actually listen to the Solana blockchain for us and send us back logs. So that's what we are doing now. So once we have a WebSocket instance, they have some kind of listeners and they can listen for a lot of things. But for example, when it closes, we can actually automatically open it again. When there is an error, we can console out like, hey, there is an error with the WebSocket. When we actually receive a message, we will come back to that later, and when the WebSocket opens. Now, to use the WebSocket, ideally we need to subscribe to a RPC method. And all these RPC methods that we can subscribe to, they are actually Solana RPC methods. And you can find them on the Solana documentation. And you have HTTP methods, but we are using a WebSocket, and we will subscribe to the log subscribe method. And you can also read more about these methods here and what they do. But in short, the method that we will subscribe to is the log subscribe. And what it does, it will return like logs related to certain things back to our program. So as you can see, this is the information that we need to provide, and we can also mention something here. And earlier I talked to that we will only look for new tokens on the Raydium market maker. So what we can do is provide the Raydium market maker ID here. So you can copy this really easy, and once we initialize the WebSocket, we created a function for that where we can provide these instructions. So we say we want to subscribe to the log subscribe method. We want things to be mentioned. In this case, the liquidity pool Raydium program ID. So all these things I store in some kind of config file, which I also import on the top here. And we can have a look at this config file. It says config liquidity pool, and then you have the Raydium program ID. Also, this you can copy, or you can just Google Raydium program ID and you will find it really easily. So that's the Raydium program ID. And that's really important for us because we want to only receive logs that are related to the Raydium program. Nothing else. We don't need anything. We will already receive a lot of logs because, as you can think, there is a lot of things that happening on the on Raydium. So we can have a look. Once we receive a message, we of course need to analyze that message. And that is actually the next step, as I said before. So the RPC is set up. It will talk to the blockchain. And once it receives the logs, in our case related to the Raydium market maker, we can actually take these logs and we need to analyze them. Now, really important, I can show you. If I would, for example, console log out these logs that are coming in, you can see that we will receive a lot of logs. So let me have a look. Are we... Yeah, this should be fine, parse data. So for every message, we want to log this out. So yeah, that should work. So if we start it once more, let's see, npm run dev. So here you see that the WebSocket started, and these are all these log messages that we receive constantly. And these are thousands of log messages, because you have to think we receive log messages related to purchases, related to sales. So our next job, or the job of the script, is to actually find out the logs that are related to liquidity pool creations. So the good thing is these logs, and I can show you if we would, for example, go to SolScan. Every transaction, every signature, there is some kind of logs related to this, and they have some kind of instructions, and based on these instructions we know what is happening. So in our case, what we need to do is look through these logs, and I can also output them for you so you get a better understanding what is happening. The only thing we do here is export the logs from the parsed data. So if I run this once more for you, let's stop this one. You see that we have like all these kind of logs here. And if we stop this, these are related to transactions, signatures, everything related to the Raydium market maker program. So these logs are actually the same as these ones here, only SolScan provides a better UI for us and it's a bit more readable. So what we want to do with our script is actually looking into these logs with some kind of logic, because logs is for us like an array, and that's also what we check here. And we want to check in this array, do we have instructions that are like initialize to or initialize instruction to, because we know that these instructions are related to a new liquidity pool creation. So that's the part that we are looking for in these logs. All right, so let's say that we got a log back that is related to the Raydium program, and that is also related to a liquidity pool creation. If we know that, we can take this log, the signature from the log, and we can actually look up the transaction details. So that's the next thing that we need to do. So we found the log. We know that it's related to a liquidity pool creation, and this actually just returns true or false. If this is part of the log, it's true. If it's not, it's false. So, and if it's false, we do nothing, we return. If it's true, we move on. So here again, we can say that a transaction is ongoing because now we actually found something that is interesting. And in order to handle this transaction, we also want to make sure that the WebSocket stops listening for now at least. So we can do that with saying WebSocket close. 1000 is the status code for that, and we can give it some instructions or some notes on why we are actually closing the WebSocket listener. We can then output some console logs like, hey, we found a new liquidity pool and we paused the WebSocket because we are going to handle a potential transaction that we found. So then the next thing is to fetch the transaction details, and also this we will log out so we know exactly what's going on. Now we are fetching the transaction details. And if we go back to the diagram, that's where we are right now. So we have the log, we take the signature from that log, and based on that signature we can create an API call, also Helius, and I will show you the documentation what exactly we're going to do. And that API call will return us back the actual transaction that is related to this signature. So if we go back here, as you can see, we created a separate function for that. And this function is called fetch transaction details, where we just provide the signature that we extracted from this parsed data from the actual log. So fetch transaction details, this function here also will make an API call, and again the URL for that is in the environment file, and I can show you which URL I use. It's the Helius parse transaction URL or API endpoint. You can find it here. You can also find more information about this endpoint and what it does. But in short, we will provide it a signature and it will provide us the transaction details back, because that's important, because we need these actual transaction details to export more information from that. So I can go over it real quick. This is just an API call that we make to this Helius endpoint. We provided the signature and it says transactions here. And if you look back at the documentation, it will also say what we need to provide. For example, here, transactions. You can test it. You get some kind of an overview of how a request and response would look like. But in short, we just provide the signature that we parsed into this function, and we will get a response. And we check, of course, if we got a response, and if we do, we move on. So here, once we receive a transaction or these transaction details, we need to write some logic, of course. We want to make sure that these transaction details contain instructions, and we also want to make sure that it's related to the program ID, which is Raydium. And if all that is the case, then we move on and we extract the token mints. And the token mints that we want to have is the Sol token mint and the token mint from the new created token. And if that's the case, if we find these token mints, we return them in a nice fashion, token mint and Sol mint. So we can actually use them back in our script here, where they are returned in data. So really simple. This fetch transaction details uses this API from Helius. We provided the signature in the body and we get back some kind of response, and you can see how this response will look like here if you want to know how it would look like. But the thing we are looking for is the instructions. Then we have in program instructions, program ID. This is what needs to match to our Raydium program ID. And then in accounts, we will find more information about the token mints. And you can see also that is what we are doing here. If we go back to the function, we have the response and we look for instructions, and within these instructions we check the program ID if it's related to Raydium, and if that's the case, then we take the accounts, and from the accounts we know at number 8 and number 9 are the token mints, and then we verify which is the Sol token mint, and then we store that in Sol token account, and then we also automatically know what is the new created token mint. So that's all it does, nothing more. I think it's really interesting or important that you check the documentation how this parse transactions API endpoint work, and then you can actually provide any signature and get the transaction details back. So that's what we are doing here. So we're using these Helius endpoints. Again, we parse the transaction signature and we get back the transaction details, and we take out the Sol and the new token mint. All right, now that we have both the token mints, both for Sol and for the new token, we have actually the token pair. And the next thing we need to do is make sure that the new token that we found, that it's not a bad token. So what we need to do is called a rug check. And a rug check is something that just goes and looks for a lot of kind of things. Is it like a copycat token? Is all the supply burned? How much of the tokens is held by the top 10%? But for this, we can actually use a third-party service again. There is something called rugcheck.xyz, but they also have a really good API that we can use. And it's also really well documented. So the endpoint that we will use is called tokens, I guess. And here we can provide a token mint. Let's say if we want to test this, for example. So let's try it out. We can just go to GMGen or any website where we can find a token really quick. So if we take this token mint ID and then we go back into the tester, we execute, and you see that we get back some kind of information. So we know that it's a low amount of liquidity providers. So this token looks actually okay, but it's also an older token. I think I have a key from a token that doesn't look so good. So if I go back to one of my tests here, I can take this token idea and we can run it, execute it. So here we have a bad token, for example. So we know that the top 10 holders have high ownership. Single holder ownership is 79%, low liquidity, high ownership again, mutable metadata. So these kind of things we get out of this API endpoint just by providing the token mint. And we have written some logic for that. So if we go back to our script here, where did we leave off? We fetched the transaction details, we stored them into data, we check if we received valid data, we also check if we received the token mint and sol mint, the ones we returned earlier. And if that is the case, then we will do a rug check. And for that, we also created an additional function. So if we go and look at that, what we do here is using the API endpoint. And also this again is all documented. If you go to rugcheck.xyz, then you go to API on the bottom, you will end up on the API documentation. Then you go to tokens, and here you can have a look on how such a request and a reply looks like. So that's the only thing we do. We provided the token mint from the new token. We request like some response. If we get a response, we export the data. And then we can, of course, build some logic around this data to see what we want to do. So I created a few checks here. For example, if this response has single holder ownership, for example, too big, then I don't want to do it. Then I return false and it aborts the transaction. And I also have it in config rugcheck, single holder ownership. Again, we can have a look at that. I set it to 30. So once it's bigger than 30, I don't want to proceed with this token. We can also do some other kind of checks. We can go through the through all the things that were returned by this API, and we can say if any of the following is in there, we don't want to proceed. So for example, if it contains freeze authority still enabled, large amount of liquidity pool unlocked, copycat token, if it contains any of these things, then we don't want to proceed, because for me, these are too risky of tokens. So you can build, of course, your own logic. You can say, if this says, I don't know, top 10% holding, you can change this. And then in config, you can write something like 30 or 10, and then we can update this value here. Or if you say, I want to have single holder ownership, we can also add this here in our array and do like this. It's up to me or to you on how strict of a rug check that you want to perform. So this is actually the logic for the rug check, and this returns true or false. So if we say it's too risky, we return false. If we say, okay, we are fine with the report that was returned, we return true. We can also see that here in our rug check, it passes into is rug check passed. Even it's false, we just console log out like rug check not passed, transaction aborted, and we start the WebSocket handler again. If we say, hey, this token looks actually okay, then we move on. And the next step that we need to do is actually making the swap. So to recap, what we did here is we took the new token mint, we created an API request with this third-party service called rugcheck that returned us a rugcheck report. And then based on this rugcheck report, we can make a decision here somewhere like, hey, Do we want to buy this token? Do we want to swap our Sol tokens for this new token? All right, so now that we have both the token mints, we have a rug check that came back and we think it's okay. We are okay with buying this token. We can actually proceed to buying the token, making the swap transaction. And to do that, we also use a third-party service. It's called Jupiter, and you can also find information about that V6 swap API online. If you just go to station.jup.ag, then you can go to documentation, and under swap API, you can read what this actually does and how you can implement it. And our script also just uses all the steps that are described here. But what it does is really easy. We will provide some kind of instructions or a document. It will create a quote for us, and that quote we can sign with our wallet. That will create some kind of transaction, the signature, and that will purchase the token for us. So we can look at that in our script here. So we were okay with the rug check. It was approved. It returned true. So we can move on. I also have an additional check here that skips pump tokens for now, because I think the Pump.fun tokens, they are quite volatile. So once they are created, they shoot up really quick, but they go down really quick as well. So it's really hard to get some proper profit from that. And the thing how I do that is all the token mints that are related to Pump, they end with Pump. And I can show you here, if you would, for example, go to meme and then just open, for example, this one. If you copy this one here, the token mint, and you paste it here, for example, you see that it ends with Pump. So we know that all the token mints that have Pump at the end, they are liquidity pools created from tokens that were actually bonded on Pump.fun. And these are really volatile. So what we do here is, if the token mint ends with Pump, and we set it to true, because also in our config, we can set it to false to take the Pump tokens, but for now we set it to ignore. If that's the case, then we will just say transaction skipped, ignoring Pump.fun. But if it's not a Pump.fun token, or we allow Pump.fun tokens, then we move on. We console log again that we found a potential token that looks interesting to us and that we want to continue with making a swap. To do that, I created a separate function again. It's called create swap transaction. And if we go here, we can have a look at what we need. Most of the time, to make a swap, you need a lot of information, you need a lot of different pool keys. But as I said, we will use some kind of third-party service for this as well. It's called Jupiter. And if you go to the swap API documentation, you can actually follow through the whole documentation. You can read what is needed, how to actually create a wallet, to provide the private key, create a request for a quote, then you need to serialize the quote, then deserialize the quote, you need to execute the transaction, and eventually you will sign the transaction and send it to the blockchain. So that is what we do here. Again, I specify all the URLs that I will use. Again, they are in the environment file here. Stored the quote URI and the swap URI. They are in here. So if you go back here, that's where we load this in. We have a wallet that we have set up. You can use any like module or library if you want to set up your wallet. You need to just provide it in the correct format. But you can use the same libraries here. We use wallet library from Anchor. I think it's officially for Solana. You need to decode it properly. There is some libraries that we use to do that. And of course, we have the private key that is also again in our private key variable here. So if you want to find your private key, you can always go to your browser if you use Phantom app. If you log in, I have a test account here, so we can use later to test this bot. It has like 0.05 Solana in it, so you can go to manage accounts, you can click on the account, then you can do show private key, you enter your password, and from there you can actually copy your key and then store it in the environment file. And that will create a wallet instance for you that you can then later sign the transaction with. So that is what we do here. We prepare all these variables so we can move on. Here we do the actual quote request. So again, this is just an API call that we do here. And also this is really well documented. This is the quote request that we do here. So what we need to provide is the SOL token mint. We need to provide the output mint. In this case, this is the token that we want to swap for, or the new token, the amount of SOL. And this is in Lamperts, I guess. So you can use a Lampert converter if you would look for a Lamport to SOL. You can actually enter it here, and that means 0.0.1 SOL is like a big amount of Lamport. So, and we provide the slippage that we want to use when we buy these. Also, these are for me stored in the config file. So the amount is 0.01 SOL and a slippage of 2%. So that's just to test the bot later. So that is the first API call that we make here to receive a actual quote. And again, you can go back to the, let's see, where was it? The information here on how this request looks like, and then the response that you get and what you need to do with that response. So this is the next step. I just copied that code. This is the swap transaction. This is just the endpoint or the request copied swap URL that you need to use. Also, you can just find it in the documentation. It's all documented. You enter it here. You see what you need to provide. In this case, the response of the quote we need to provide. We need to provide our public key from our wallet. We need to provide, if we want to unwrap the SOL, we want to the slippage. We provide some other things if we want to prioritize, if we want to how much Lamperts we want to use for making the swap, the priority level. All these things are documented, but these are actually needed to make this call. And once we make that call, we get back a transaction from the swap API, which we then in turn need to deserialize. And also this is all documented. I just copied this. This is what we do here. The data that we receive, we handle it, we verify, decentralize, just like the documentation says. We sign it with our own wallet that we set up here earlier, my wallet. And then the next thing we do is getting the last block hash. Also, this is all documented here on the swap API, how you can do it, what you need to provide, and we move on. And eventually we execute the transaction. Also, this all documented, and we confirm the transaction. And once it's confirmed, then we will return the transaction so we can have a look at it. So that is actually the next step that we are doing here. Once we are happy with the actual token and the rug check was completed, we use this third-party service that we send all this information to. We get a quote, we sign it with our wallet, and the transaction has been sent to the blockchain. And then we use confirmation of the transaction to output it. So again, most of this code is just been copied from the actual documentation. So if you read through this, you will really well understand what is happening, why you do this, and also how the transaction is actually signed and put on the blockchain. Good thing to know, this is also free, so you're only charged for the fee actually for the transaction. They don't charge any extra to make this swap for you. So it's really well documented. Have a look at it, read through it. But that's actually the code that I use to make the swap. That's it. That's the whole bot. It's quite straightforward. We use a lot of third-party services, nothing really fancy, but I've seen that the bot buys on average in 10 seconds, which is really quick because we are using all free services. And also, for example, Helius, they have paid services, which you can pay for RPC nodes, which are much quicker. And of course, this will improve the time of the bot. But for using all free services, I think this is working really well. And that's how my Solana Sniper is working at the moment. Alright, so now that we know how it works, and once the transaction is returned, we make sure that an actual transaction is returned. If not, we log out that no valid swap quote was received. But if it returns a transaction, then we just log out like swap quote received, swapping sulfur token, and all the steps that we actually did in the create swap transaction. So once that is logged out, we are done with handling this transaction. We bought the token and we can start the WebSocket handler again, or the WebSocket listener, to start listening for new liquidity pool creations. So that's how it works. I think it's a good time to give it a spin and see how it actually acts in real life. So to do that, we just go to the terminal and we run npm run dev, and that will start the actual WebSocket and starts listening for tokens. And I think I still have some kind of console log on, so let's see if we can turn that off so we don't see all these, like all the logs being logged out. So did we have it here? Yep. Let's remove that. Now we can clear this and then we can try to start this again. So now it's listening and it found something here. So it says new liquidity pool found. It's pausing the WebSocket, fetching the transaction details, and for some reason it timed out, so it aborts the transaction, which is also really good because we don't want anything going wrong, or we don't want to end up with a half transaction or a invalid quote. So it just aborts it and it moves on with listening again. So I will speed it up, and once there is a potential transaction that comes through, or we're buying a token, I will come back and then we can analyze the token. We can look on the chart and see if we can make any profit really quick. So it seems that we found a token right now. So let's have a look. This is the token that we should have bought. Trump BTC. Looks like something catchy to me. But here you can see that we bought really early on, I think 15 seconds in. And the moment we're only 1% up. But you see that we bought really early on and the price should only go up from here. Ideally, I would have a rug check to have a bit of more holders, because I'm not really happy with like only 28 holders, but that's it for now. That's why we have the rug check and we can improve on it. But as you can see, we bought really early. The price was really low. The token only goes up from here. And I'm quite confident that this will be dropping. This will be rug checked. As you can see, we are like 2 minutes in and we have like almost 3% profit. Of course, we're having only 0.01 SOL that we bought. So that's also not that much. So we will lose probably most of our profit just on the transaction fees and the high priority that we set when we bought the token. But the point that I want to make is that you can buy the tokens really early. And as you can see, you can take some profit after a few minutes if you have some rules in place. So let's do that. So if you can see, we now sell. We don't get so much back, of course, because of the fees. That's fine. If we do this with a bit of bigger amounts, then we will for sure make some profit. So that's how we made like 3-4% in like 3 minutes. And that's the purpose of the bot, to buy really early and sell after we made some decent profit after a few minutes. So that's it.